Hello. For this set of problems, it's a hypothesis test for proportions. And so we fill in this gray area. Looking at the first one, school reports that 90% of its graduates get jobs within 1 year. You take a random sample of 65 graduates, of whom 54 got a job. Is this enough evidence to show a significant smaller percent? And so the study should be a hypothesis test for a proportion. Then this will be P because it's not an average, it's a proportion. Null hypothesis is always equal to, and then the one you're testing, which was the 90%, written as a decimal 0.9. Now we want to test smaller, so our P is less than 0.9. So P and the 0.9, whatever's here is always here. The only thing that changes is the equal to. It's either less than, greater than, or not equal to. Since we're testing smaller, it's less than. To find the values, we plug in here. Our level of significance, alpha was 0.1. 0.1, enter. Sample size was 65. The number of the ones that said yes was 54. And population proportion comes from the hypothesis 0.9. Your test statistic is here. The p-value, since we're testing less than, it's a left tail, so it's the 0.0314. If the p-value is less than alpha, 0.03, alpha's 0.1. So alpha is less than the level of significance, so we reject. For this one, I'll clear my data. Test the claim that the proportion of men who own cancer is significantly different than 30%. So significantly different means not equal to. And it says proportion, so we know it's a P, so that would be this one. It is not equal to is two-tailed because greater than or less than. To find the test statistic and the critical value, we plug into here. So my level of significance was 0.1. My sample size right here, 300 pets. Yeah, 300. The number of yeses was 22%. When you get percent, you could plug it in here. 0.22. And then the proportion was 0.3. Test statistics right here. The critical value is over here. And it was not equal to, so the critical value is a two-tail right there. The p-value is this 0.002, which would be less than the level of significance, so we reject the null hypothesis. 15% of all Americans suffer from sleep apnea. A researcher suspects that higher percentages of these live in the inner city. Of 325 people, 65 of them suffer from sleep apnea. What can be concluded at a level of 0.05? Now, this is a z-test for a population proportion because our sample size is large. I'm going to open a new one. When you type into the sample proportion instead of yes or no, you have to reopen because it changes formulas. Okay, so level of significance is 0.05. Sample size 325. The number that said yes was 65. And the population proportion was the 15%. And 15% of all Americans suffer from sleep apnea. A research expects that it's higher. So the null hypothesis is always equal to the 15%. And then the alternative, if we want to test higher, we're testing greater than. So we plugged in our values. Test statistic is 0 equals the 2.5243. P-value, it was testing greater than, though that's a right tail, 0.005. And p-value is alpha. Based on this, alpha is 0.0058. The p-value is less than alpha. We reject.